Hi, this is lesson 8.3, and we are going to be talking about how we simplify algebraic expressions. Now, we're going to review to begin with how to factor a polynomial. So first of all, we want to look at the integers, and we want to take out the greatest common factor, and that would be 2, which means that we're going to divide a 2 out of every term. And then we want to look at the x's. We can take an x out of every term, and we can take one y out of every term. So we're going to divide the numbers. 16 divided by 2 is 8, and if we take out the x, there won't be any x's left, and if we take out a y, we'd have one y left. Next, we go back to dividing. Divide negative 8 by 2, we get negative 4. Take out an x, we have one x left, and we take out a y, there would be no y's left. Finally, negative 2 divided by 2 is a negative 1, and the x is coming out, the y is coming out, so that's it. In the next term, we're going to factor this. We can divide a 2 out of both parts, but we can't take an x out because the second one doesn't have an x. So we're going to factor out a 2. So 2 divided by 2 is 1, and then we would have x squared. 98 divided by 2 is 49. And when we factor, we always look to see if we can factor again. And this, in the parentheses, is called the difference of perfect squares. So remember, that will factor into this pattern. X times x, and then 7 times 7 is 49. And because we don't have an middle term, we have to have a plus 7x and a minus 7x, which would cancel your middle term. All right, next, we can't take out a common factor, but that is a trinomial, and we're going to try to factor that into two binomials. Hopefully you have your purple factor sheets that you can use. So we want to look at the factors of 22, 1 times 22, and 2 times 11. The ones that add up to 13 are the 2 and the 11, but we want those to give us a negative 13. So they both have to be negative. So negative 2 and a negative 11 give us a negative 13, and then we have to double check. If we take a negative 2 times a negative 11, yep, that gives us a positive 22. And then we are going to skip the next one for right now. All right, a rational expression, that's kind of hiding right there, is the quotient of two polynomial, let me see if I can move this. Nope, it's not moving. So a rational expression that's hidden behind the camera there. It is the quotient of two polynomials. I'll write that word, rational. Now I have some examples. The first one is 2x squared, so it's a polynomial, divided by y, which is a polynomial. Then you have another one, x plus 1 over x minus 1. And then the last is x squared plus 3x plus 2 over x plus 3. So something that is really important to understand here is whenever you have a plus and a minus, it's like there are parentheses around them. So right here, it's like you have parentheses. So it's a good idea just to put parentheses whenever you see a plus or a minus in the numerator or denominator. And what that needs to remind us of is that you can't go in and cancel just a part. So like in this example right here, you have an x and an x, but because the x they're both in groups of parentheses, you can't go in and just cancel x's. That would be wrong. Or in this next example right here, you can't go in and just cancel x's. Okay? You can only cancel if you have identical terms. So look at this next set here. These are not in simplest form. And here we don't have any pluses or minuses in this first example, and we can go ahead and cancel x's. So this x goes into x one time. If you cancel 1 up here, you'd have 1 left, so that equals just an x right there. The next example, notice you have negatives, so I'm going to put parentheses around the bottom. Whenever you don't see the parenthesis, put it there. And when you have the exact factors, like a factor of x minus 3 and a factor of x minus 3 on top, you can cancel. And so we're just left with a 5 for an answer right there. And then this last example, again, we see pluses and minuses, so we're going to begin by putting parentheses around. Whenever there are pluses and minuses, put parentheses around. Then what you always want to do is see if you can factor the numerator. So we would have x times x. The factors of 6 that have a difference of 1 would be 3 and 2. And actually we want a negative 1. So we're going to put a negative on the 3 and a positive on the 2. So minus 3x plus 2x would give you the 1. Now since I factored it, I'm going to cancel that. Next, I'm going to try to factor the denominator. So x times x. The factors of 2 are 1 and 2. And we want to end up with a positive 1, so we're going to put a positive on the larger number, the 2, and then minus 1. 2 minus 1 would give you 1x. Negative 1 times 2 is a negative 2. So you want to factor them, and at that point, if you have common factors, you can cancel. And if we look at the numerator and denominator, they both have an x plus 2. So those cancel, and so our final answer, we have an x minus 3 in the numerator and an x minus 1 in the denominator. And you can keep the parentheses around the numerator and denominator, but at the end you don't have to write them when we're not trying to cancel or simplify. All right, here are a couple more examples. We don't have a plus or a minus, so we don't need to worry about writing parentheses. So what we want to do is look at 63 and 27, and you could use your calculator and type in 63 ABC 27 and reduce it. Or we could say, okay, 7, let's see, 9 goes into 63 7 times. 9 goes into 27 3 times. And then we look at the ends. There's 1 on the bottom, so you can cancel that. And if you cancel 1 on top, you'd only have 1 left. So the final reduced answer would be 7n over 3. So reduce the numbers. You can use your ABC button. In the next example, you can use ABC and you would get a negative 4 on your calculator, which would be negative 4 over 1, or you can think of it this way. 6 goes into 6 one time, 6 goes into 24 4 times. And now the x's will cancel. You have 2 on the bottom, and if we cancel 2 on top, we'd only have 1 left. So we have 4x, and then keep track of what's in the numerator and what's in the denominator. You have 2 on top, and if you cancel 2 on the bottom, you'd have 1 left. And that y is in the denominator. Now the other thing we need to talk about is this negative sign and the 1. And the 1 we don't have to write. You can write 1y. And when there's a negative, you could write it in the denominator, or you could write it in the numerator, or you could just write it out in front. So that's my answer. So that's a lot like what we did with exponents. All right, now the next examples here, we see pluses and minuses. So the first thing we do is put parentheses around each expression. So then we want to look for a common factor. So we don't have like x squared kind of thing. So we don't need 2 sets of parentheses, but we can take a 10 out of both. 10 divided by 10 is 1k, plus 20 divided by 10 is 2. So you're dividing numbers. The next one, looks like we have a k squared, so we do need 2 sets of parentheses. It's a trinomial that we're going to factor into 2 binomials. We need to end up with factors of 6. 1 times 6, 2 times 3, and they have to have a difference of negative 1, so we're going to do the 2 and the 3. And we will put the negative on the 3, because minus 3 plus 2 gives you a negative 1. And now we have a k plus 2, or 1k plus 2, and a 1k plus 2, so those cancel. So then you write down what's in the numerator, a 10, what's in the denominator, k minus 3. I'm struggling with that word today. And that's your final answer. All right, one more example. It's a trinomial. So we're going to try to factor it into two binomials. So you would have x times x. 2 times 4 is 8. And we want to end up with a positive 2, so we're going to put a positive on the 4. 4 minus 2 is 2. That would give you 2x in the middle. So I'll cross that out. And then we factor the denominator. So we have to think about this. We have different ways to come up with a 5, 1, and 6. So if we did 6 or 1 minus 6, that would give you a negative 5. But then you'd have a negative times a positive, which would make a negative 6. So that does not work. So we're going to have to use 2 and 3 and make them both negative, because then you have negative 2 times negative 3, which would give a positive 6. And when you add negative 2 and negative 3, you get negative 5. From there, the x minus 2's will cancel. So in the numerator, you have x plus 4. In the denominator, you have x minus 3. So that is reduced. Last problem, x squared plus 7x plus 10 over x squared minus 3x minus 10. So we have two trinomials. So again, we get good review of our factoring. So the factors of 10 are 1 and 10, 2 and 5, and we need the ones that add up to 7. So we'll pick 2 and 5, and they're both plus. So if you have a trinomial, try to factor into two binomials. All right, factors of 10 are 2 and 5. Again, looks like we're going to use. And we want to end up with a negative 3, so we'll put a negative on the largest number. So negative 5 plus 2 gives you that negative 3. And 2 times negative 5 is negative 10. And so we can cross out the x plus 2's. We're left with x plus 5 and x minus 5. That's our final answer. Now, at the end it says state any restrictions on the variable. So whenever you see something like that, or if you see a question that talks about the domain, remember domain is another name for the x's, what the x's can be. So we have to think about what number can you never have in the denominator of a fraction. And that's 0, because that would be dividing by 0, and you can never have a 0 in the denominator. Okay, we can't do that. That would be like if I asked you guys to stand up right now and to get into groups of 0. It's not possible. You can't divide by 0. So you have to think about what could make the denominator equal a 0. So what you can do is you can take each factor, x plus 2, and set it equal to 0. X minus 5, set it equal to 0. So if I put in a negative, or I solve that, so x would be a negative 2. Solve this one. X would be 5. So here's the thing. What that just did is, if you look at the denominator, x squared minus 3x minus 10, if I plug in a negative 2, I would put parentheses around that negative 2. That would give me 4 plus 6 minus 10, which would be 10 minus 10, which would be 0. So if I were to substitute in a negative 2, I would get a 0. Okay, so that's saying, what we're saying here is that x cannot be equal to negative 2, because that would give us 0 in the denominator. Then if we test the 5, you would have 5 squared minus 3 times 5 minus 10. That's 25 minus 15, which would be 10, minus 10. Sure enough, you would end up with a 0. So then you say x cannot equal 5. So the restrictions on that problem are that x can't be a negative 2 or a 5. All right, go ahead and work on worksheet 8.3. Thanks for watching.